Hello, this is presentation of final project work of basic data analysis. Our group consists of four members: Kalom, Ravidu, Mohini, and myself, Charit. Uh, in this data set includes detailed transactional data generated from various retail and e-commerce platforms accurately representing typical US consumers trend. Key features of the data set is there are the transactional data details such as purchase data, value, product category, payment methods, and customer information such as demographic data about customers, age group, gender distribution, location distribution, and shopping behaviors such as frequency of purchases, average spend per transaction, and seasonal trends. In here in the data set, gender distribution is about male distribution is 60 males representing 68% of data and females 32%, and age distribution is from 18 to 70 years. Uh, we have taken this data set from as source as from Kaggle. Considering the characteristic of the data set we are working with, there are 3,900 rows for analysis. We have cleaned data set and frame does not contain any non-number values, but we have checked for non-number values and also cleaned the data set using drop null values. Uh, First, we the project we import pandas as PD and import NumPy, and also import Seaborn for heat maps, and also import library for graph to create the graphs. We have uh, checked the at key attributes of three key attributes such as nominal attributes, gender, item purchase, category, location, size, so on. And as a binary attributes, we uh, got the as got gender, subscription status, discount applied, promo code. As an ordinary attribute, we have only one ordinary attribute. It is a review rating. For the next part, I invite to Ravindu to over to you, Ravindu.
Yeah, thank you, Jait. So I am going to explain few of the tables we make in this project. So Jait, can you go down to first one for some says this one. So in here we basically we compare the sum of previous purchases and total purchase amount in their in terms of the absolute totals. And visually present this comparison on a plot. This help us to understand in the relationship between the two variables in terms of their total value. Here we visualize the data. We made a line graph with 2 points, each representing one of the totals, shows the difference between the two totals. The plotted values are connected by a line and markers. We use circles as a markers, highlight the two total values. The actual value are displayed above each point on the graph and using the PLT text function showing the numerical comparison. So there are also some other charts and graphs we make here. So I am not going to go through each and everything, but here I am going to explain a few of those. So there is a there is another. Actually, this is not a chart, but can you go to the calculate minimum and maximum purchase section? Uh, Here we calculate the minimum and maximum values for both purchase amount and the previous purchase in the sales data frame. The calculated values are then printed out to give insight into the range of the data for these two columns. In here, we use pandas for accessing the columns and calculating the minimum and maximum values. We aggregate the sales data to count how many items are purchased in each season and then visualize the result using a pie chart. The method used primarily from the Pandas library for the data manipulation and Matplotlib for chart creation. The final output provide both printed summary of the data and visual representation via pie chart. Then can you go down to count of item purchased by season? There's another column we created here. Here, this table shows count of items purchased across the different seasons. So this is a bar chart where each bar represents an item purchased. Different colors in each bar represent different seasons. The height of the bars indicates how many times that the item was purchased in that season. This code is useful for visualizing the distribution of item purchase across the seasons. Can you go down to total purchase amount by season? Then item. Yeah, here. Next, we create a bar chart where each bar represents an item purchase. The bars are divided into columns, colored segments, each corresponding to a season. The height of each segment corresponds to the total purchase amount for that item in that season. Each color in the bar indicates a different season. This visualization makes it easy to compare how much was spent on each item in different seasons. We compare the sales volume and average rating by location in this bar chart. The bar chart will display sales volume for each location. The line chart will overlay the bar chart average rating on the same plot. The x-axis will have locations. The left y-axis will represent sales volume and the right y-axis will represent average ratings. So here you can easily identify which location have the higher sales volume and whether there are any correlation with their average ratings. These are the table charts we are going to explain here. So there are so many other things. Over to you, Rohini.
Yes, thank you, Shravidu. As we all know, one of the most important aspect of data analysis is data visualization, where the actual picture of the data set is presented to the decision makers. In this data set, we have created a few graphs that will help us visualize key insights. Let me go through each of these visualization one by one. First, the bar chart shows a comparisons of total purchases between the last 2 years, broken down by season for a clear view. As you can see, sales have almost doubled in each season. However, when comparing sales across different seasons within the same year, there is no major change. Next, the pie chart visualize seasonal sales in terms of the number of items sold. Similarly, there is no significant variations between seasons. All seasons have relatively consistent sales. The third visualization is another pie chart which shows the number of items purchased by product category. Strangle set to 140 and lowest purchase product starts here, and it is arranged in order of the least purchased product to the most popular product, which is blouses. Moving on, we have a bar chart that highlights the product with higher demands during each seasons. The clothes color blue orange, yes, this one, green and red represent the fall, spring, summer, and winter seasons, respectively. As you can see, jackets have the highest. Demand during the fall seasons, white backpacks have a lowest demand in winter. I have also created a bar chart showing seasonal purchase in terms of values broken down by product. This chart helps to understand how each product contributes to overall sales value in different seasons. The heat maps is another important visualizations offering a comprehensive view of sales performances. It ranged from light blue indicating lower sales to dark blue indicating higher sales. From the heat map, we can observe that hats in the fall of sweaters In the spring, generate the highest income, whereas sweaters have a lower demands in the summer. The next chart is a bar chart showing sales for each distribution center, paired with the lines chart displaying customer views. Here, for each center, we can see the West Virginia has higher sales, but its consumer service rating is low. On the other hand, Texas has a higher level of consumer satisfaction despite lower sales. Next, the bar chart shows the age category of the client base. As you can see, most purchases are made by individuals in the 36 to 65 age groups. Additionally, in every age groups, the male client base makes up a large portions of the purchases. When we look at the total purchase of value, it becomes evidence that the 36 to 65 age groups is the most significant contributors to overall sales. Finally, we have a pie charts that compares purchases across age groups as a percentages of total purchases. Darshana?
Yeah, thank you, Rohini. In conclusion, as my colleagues have explained, we utilize the dataset to create various visualizations using Python. This includes pie charts, bar charts, line charts, and heat maps, all designed to provide clear and actionable insights for decision makers. To achieve this visualization, we employed several Python libraries such as Pandas, Matplotlib, Seaborn, and NumPy, which allows us to process the data, analyze it effectively, and create meaningful visual representations. Here are some key methods and steps we used. In data aggregations and grouping, we use Pandas method like group by and pivot to organize the data. For instance, to calculate total number of items purchased by season, we grouped the data by season and used .count to compute the values. In pie charts, we use matplotlib plt.py method to visualize proportions such as the distribution of item purchase across season and product categories. The AutoPCT parameter was added to display the percentages clearly. In bar chart, for a more detailed view, we created both stacked and unstacked bar charts using matplotlib plot and bar methods. And then heat maps, we utilize Seaborn's SN heat map function to create a visual summary of total purchase amount by item and season. This provide quick gallons at high and low performing segments. In line and combined charts, to compare sales volume and customer rating by location, we use a combination of bar charts for sales volume and line chart for rating on the same graph using the twin axis method in Matplotlib. In data binding for age group analysis, we define age bins using pd.cut and assign labels to each bin. This allows us to segment the data and analyze total purchases or customer distribution by age group effectively. Stack bar charts, the age gender distribution was visualized using a stack bar chart created with Pandas and Matplotlib, showing the contribution of each gender within different age categories. And these techniques allows us to analyze customer purchasing pattern and seasonal behaviors, and also popular products, high-performing segments, key demographic contributing to sales, relationship between sales performance and customer satisfaction. And the insights gained from the visualization empower decision makers to develop target customer segment and business strategies, build predictive models for sales forecasting and customer retention. And finally, by using these Python-based methods, we created comprehensive and actionable visual summary of the data, making it easier for stakeholders to identify trends, optimize resources, and plan future strategies. Thank you.